So this is called elimination. Now look at this problem with me. What is different about this problem than the ones we've been doing the last couple of days? Yeah, no variables by itself, right? Now we can still do these. It's just so if no variables are by itself, then we need to do elimination. Now we can do elimination by step number 1. Make sure variables are aligned. Are the variables aligned, Mallory? Mallory, are the variables aligned? The x is on top of the x, the y is on top of the y, the constant's on top of the constant. Okay? That's the first thing. If it's not, you got to get the equation so the variables are, but they will be aligned, I believe, today. If not, you got to make sure you get them where the x is on top of the x, the y is on top of the y, the constant's on top of the constant. Step number 2. One of the variables must be opposites. If there is not, make one of the equations so they are opposites. I'm really small. So, one of the variables must be opposites. If there is not, make one of the equations so they are opposites. And we're going to do one of those in a second where they're not opposites. Kellen, are one of our variables opposites? Look at these. See that? Everyone look at y. What is the y term up here? What's the y term down here? Those are considered opposites. Does everyone see that right there? So if one of the variables are opposites, we can move on to step number 3. Step number 3. Add equations together. So what I do by that is means we're just going to go. We're going to add the two equations together. So we're going to go 5x plus 2x, which is, what happens to our y's? They cancel. Equals negative 6 plus 27, which is 21. So there's one of our equations. How do we solve 7x equals 21? So step number 4, solve for first variable. And you guys drilled it. Okay, step number 5. Plug back in to either equation to solve for other variable. Doesn't matter which equation we plug it back into. Nope. So I'm going to just plug it back into the top one. So we're going to go 5 because x equals this. We're going to plug it in for x. So we're to there. Which is going to give us 15 plus 3y equals negative 6. And then we just solve the equation. 3y equals negative 21, divide by 3, y equals negative 7 there. Okay? So this is called elimination. Questions? All right, let's do another. I'm not going to write out all the steps next time, thank goodness. Right, we're just going to do the problem. So 2x plus 5y equals negative 6. Negative 2x plus 3y equals 22. Are the variables aligned? Is one of them opposites? Which one? Well, which variable is opposites? X. Register that before we start the problem. We're going to do one right next. Well, not next, but pretty quick here. Okay. So, we add them together. The x's cancel. We add the y's together. We get 8y equals negative 6 plus 22 is 16. We can solve for the first variable, so y equals 2. Look at that. Look how easy that was. What do we do with the 2? Yeah, we plug it back into one of our equations for y. And we solve again. And this is all stuff you guys should know how to do by now. Simple algebra. X equals negative 8. And there's your two solutions. Okay, I want you guys to try one on your own that has them as opposites, okay? And then we're going to start to do a couple that don't have them as opposites. So try this one on your own. Oh, that should be a 3. That's a 3. Okay, there you go. Try that one on your own. Okay, Tanner, which variable's opposites?
Which are opposites, like
Yeah.
like or are?
Well, we've been doing this whole time. Shut your computer, Tanner. You too, Easton.
That's right. Because all of them
Yeah, that's aligned. Which variable's opposite? Yeah, it's y. We have a 2y and a negative 2y, which is going to give us 8x equals 16. We're going to divide by 8 to both sides, so x equals 2. Who got x right? Griffin, no? Then raise your hand, man. Thank you. Alright, which variable did you, which equation did you guys plug it in for? Okay, fine, we'll go top. 5 times 2 plus 2y equals negative 4. 10 plus 2y equals negative 4. Subtract 10 to both sides. 2y equals negative 14. Divide by 2, y equals negative 7. Who got them right? Both of them. Not bad. What happened to you, Daxton? Yeah, didn't do it? Okay, alright. Per Griffin's request, but also per my request, we're going to do one when they are opposites. Everyone ready? It's not very much harder. So, copy down this one. So today, luckily, when we do it, when we look at them, they're not opposites, but they're close to being opposites. Dre, which variable is really close to being opposites? Yeah, the y, right? Does everyone see that? So first thing you need to recognize is which variable is the easiest one to get to opposites. There is going to be one that's easier than the other. Okay, y is definitely easier because they're really close. Now, in order for them to be opposites, one of these has to be what? A negative. So what we're going to do is it's called a manipulation. Or we're just going to multiply one of the equations by a negative 1. So what we're going to do is we're going to say your whole equation, I'm going to multiply that entire bottom equation by negative 1. So our top equation stays the exact same. The bottom equation now becomes negative 3x minus 5y equals negative 20. Yeah, so you're just changing the signs of one whole equation. But it's very important when you do this. A lot of people, when they do this, they remember to do these two, but they forget about this. It has to be all three terms. Okay? Now are the opposites. Now we go back to what we did before, so we're going to add them together. We're going to get 3x equals negative 30, or x equals negative 10. We can plug it back in. 6 times the negative 10 plus 5y equals negative 10. Hey, can I ask you guys a question? So we can plug it into this one. We can plug it into this one. If you want to, you could even plug it into the new one you created, and it still would work. So there's 3 different equations you can plug it into there. Kind of cool. All right, so we have negative 60 plus 5y equals negative 10. We're going to add 60 to both sides. 5y is going to equal 50, or y equals 10. So x equals negative 10, y equals 10. That's kind of cool. Yeah, that's cool. That's cool beans. Cool beans. All right, let's do another one that has them the same. I'm going to find this one on your homework. Ooh, it's another 5. We don't want to do another 5. We want a different number. Nope. Nope. Ooh, son of a gun. All right, here we go. 5x plus 4y equals negative 4. 3x plus 4y equals 12. I want you guys to try that one on your own. Go for it. Ready? We gotta go. Okay, hopefully everyone times the bottom equation. Now, could you times the top equation by -1 instead of the bottom? Yeah, and it would still give you the same answer. I always do the bottom one. I don't know why, I just do. Okay? Alright, so we should get 5x plus 4y equals -4, which means the top equation stays the same. The bottom equation becomes -3x minus 4y equals -12. Do we have opposites? Yes. Add them together. 5x minus 3x is 2x. -4 minus 12 is -16, or x equals -8. Who got -8? Raise your hand. Dre Stubbs, you son of a gun, you did it. Alright, Dre, which equation did you plug it into?
The top one.
Are you sure?
Yeah.
Okay, just for kicks here, let's see something here. So here's this one. Dre says, did anyone else plug it into 3x plus 4y equals 12? Alright, let's try this one. Did you do the new one? Did anyone do this one over here? Alright, we're going to test them all. You guys ready? Just to show you. Watch this. You guys ready? Everyone watching? I'm going crooked. Add 40 to both sides, so 4y equals 36. 4y equals 36. Negative 4y equals -36. Y is going to equal 9. Y is going to equal 9. Y is going to equal. Doesn't matter which equation you plug it back into. That's wild, right? Okay, so 9. So who got them both right? Raise your hand. Raise your hand if you got X right. Raise your other hand if you got Y right. Well, it's important to pay attention to science. Okay, that's it today. Any questions for me? Elimination.